I'm very pleased to welcome Dr. Robert Massey, the Deputy Executive of the RAS to Under British Skies. Welcome, Robert.
Hi, it's a pleasure to be here.
And also, Paul Harper is with us as well. Hello, Paul.
Good evening to you, Richie.
We've got a few questions for you, Robert. And the first one is, with Comet Halley due back in 2061, most of the pundits are of the opinion that it will be as bad, if not worse, than 1986. What do you think?
With Halley, it's one of those interesting, I suppose, the comet that most amateur astronomers and a lot of professionals look forward to seeing once in their lifetime. So there's always a lot of interest in just how it'll be. And I suppose with the 86 encounter, corresponding to the ages of most professional astronomers, not they're 86, but that they were of the right age to see it, very few of them have looked forward. But I did some rooting around because I was curious about this. I'd seen this written down before, the suggestion that it was going to be considerably worse than in 1986. And it turns out not quite to be the case. If you're around and of an age when you're happy to go out and look at the stars in the year 2061, it'll actually be better in the Northern Hemisphere this time, whereas last time it was good in the Southern Hemisphere, and also a little brighter. It's on the same side as the Sun as the Earth, and that makes it somewhat better. Although the distance actually between the comet and the Earth is much the same when it's closest to the Sun, but the geometry is a bit better. So something to look forward to. I'm looking forward to it to celebrate being a 92 or I think 91 when it gets here.
I remember my father taking me out and us not seeing it or not being able to identify it.
I think I was 15 or 16. I looked at it, I found it with a pair of binoculars and so on, and with an astronomical society in Bristol that I was a member of, and that was very exciting. But I have to say, it was quite hard to spot if you didn't know what you were doing. It wasn't really one for the general public, except as a general celebration of comets. So,
seem to remember Comet West in the 70s. Now that was a comet to see.
Before my well, actually not before my time. I was 7, but I don't think I was aware of it. I mean, you're right. I mean, these, they're much better examples. It's just unfortunately we tend not to know when they're around.
Ikeya Murakami C2007 V1, that's a comet which is rather a good visual comet in the not too distant future. Do you?
Well, I mean, I'm not sure that when I look at it that there's evidence to suggest that. I mean, it's what, magnitude 8 or 9 at the moment. Not really getting much brighter. There is the suggestion. I think the interesting thing about this object is not necessarily that it'll be particularly bright, but that it's going through the same kind of outburst that Comet Holmes did. It was 2 years ago, wasn't it? I think 2007 or something like that. That's probably what's interesting about it. I think it's. I mean, I was asked to comment on this, and I thought, well, I'm very reluctant to say that a comet of magnitude 8 or 9 is the kind of thing everybody should look for. I mean, it's the sort of thing you should do if you're in a dark site. You've got either a very good pair of binoculars or access to a telescope that's got a wide enough field and a low-power instrument that allows you to see this sort of object. And I guess also, actually, if you're a talented astrophotographer, it's the kind of thing to pick up. So really, it's something about the activity of that object that makes it interesting more than I don't get any sense that it's about to become something that would be spectacular to the naked eye. There was a quote about comets, which is they're a bit like cats in that they have tails and do exactly what they want. So.
Well, hopefully we'll be able to observe it at least with binoculars.
Exactly.
Do you know what happened to Comet Holmes last year? Why was it a sudden outburst?
Well, I mean, this was the return. I think the biggest outburst was 2007, wasn't it? And that was extraordinary. I mean, brightened by 500,000 times, and it was an object which is normally completely unremarkable. In fact, I would say probably beyond the reach of most people, most amateur astronomers, certainly to image at all. And the odd thing about it was that it had gone through a brightness of 105 or 115 years earlier, when it was the year it was discovered in 1892. And extraordinarily, in 2007, it did the same thing. Suddenly, it shed this vast amount of material, this dust ball around it that was very, very easy to spot. I mean, and the size of the dust ball was as big as the sun. It was completely ridiculous. And if you, again, this was an object that everybody should have been looking for, and I think actually probably didn't get the publicity it deserved, but an extraordinary object. The theories aren't entirely clear, because it's clearly very odd that something which goes around the sun every few years only goes through an outburst like this every century or so, and who knows, maybe it'll happen in 30 years, maybe it'll happen in 300 years, we just don't know, and that's what's so strange about it. And there are suggestions that somehow there's something about the structure that traps a lot of gas in there, that maybe there's some sort of crust or something that allows the gas and dust to build up, and that something allows it to escape, and the theories range from the sort of more esoteric, well, a meteorite hit it and split the crust, which seems pretty unlikely to me, through to it just the pressure builds up to a certain point where it allows it to escape. But extraordinary object. I mean, really, really bizarre. And actually, I guess it tells you that these are things to always look out for.
I was showing a load of Cub Scouts this particular comet, and they were totally amazed by it. And that was in 2007. What has been your favourite comets over the years?
Well, I mean, obviously, I guess you would include Halley simply for sentimental value more than anything else, because knowing that it was the one that, if you like, introduced. Well, I suppose you could argue it was the beginning of cometary science. I mean, Edmund Halley actually predicting or understanding that comets did go around the sun in regular orbits and that you could predict the return of some of them was a big step forward, and that they followed Newton's laws like the planets did, and Kepler's laws. I suppose you'd have to add in then actually, yes, clearly the bright ones like Hyakutake and Hale-Bopp in the 90s. Holmes is a good one too. But I think if I have to be honest about it, my favourite one is not quite so well known, which is an object called Comet Levy. And I actually liked it because it was the first time I'd gone outside from the pub, looked up and seen a comet in the sky. And I think it was visible, I don't know, in the early 90s from what I recall. It wasn't the brightest one ever or anything like that, but it was just so satisfying to walk out and think for once, rather than having to root around, not that I did it so much living in the too close to the centre of London at the moment, but to actually not have to go out and root around over the sky and look for a faint object, but to see something that easily was really very, very satisfying. So I always had a soft spot for that one too.
It's been said over the years that Jupiter is either stopping a lot of comets and asteroids coming into the inner solar system, or alternatively throwing them into the inner solar system. Which side of the fence do you fall on?
Well, it's a really good question. I mean, again, I enjoyed looking through some of the references on this, and if you go back a few years, you find there are papers which certainly in the 90s after Shoemaker-Levy 9 hit Jupiter, that was a whole string of comet pieces that hit it. That theory really held sway, the idea that Jupiter was protecting the inner solar system. And then there was some models done a few years ago which suggested that actually it wouldn't be quite so good, that in some cases it would just as often throw comets into the solar system as deflect them. So, and yet more recently, the argument seems to have turned around again. And I suppose, if you want visual evidence, it's things like the more recent impact on Jupiter. Was that earlier this year or last year, where another mark appeared, and that's seen as evidence of another small comet hitting the planet. So, but I have to say, I think the jury is probably still out. It's if you put it down to gut feeling or having a big object with a strong gravitational field, instinctively sounds as though it's helpful, but it also then leads us into ideas about extrasolar planets, about planets around other stars, and whether or not a precondition for having a habitable region of a solar system is having something like Jupiter at the right distance or not. And again, I think that the jury is very much out on that.
So a bit like the Jalise 581 system, where you have a large Jupiter body further out, not a hot Jupiter, but
Exactly. If it's this idea is that it's actually this sort of cosmic vacuum cleaner, that it moves around and income, or some anyway, a long period incoming comets are deflected out of the way. I mean, there is reasonable evidence that large cometary objects haven't hit the Earth in significant numbers. So perhaps that's quite encouraging. Perhaps we do have some degree of protection from this. And it is certainly also incredibly interesting that after the Shoemaker-Levy impact, which everybody thought was so incredibly rare, that within 20 years we see at least one more of those, that within 2 decades there have been 2 objects hitting Jupiter of significant size.
Jupiter's basically acting like the cosmic goalkeeper, or the solar system's goalkeeper.
That's fair, or I prefer the kind of vacuum cleaner, scooping up these things all through. Actually, I think you're right. Goalkeeper's a better analogy, something that kicks comets out of the way.
And occasionally it might miss, of course.
Exactly, or it might be an own goal, which I think is more expensive towards us. I mean, the argument, there were 2. I checked out the authors of this. It was Barry Jones from the Open University here in the UK, who led one of the studies that said that it might be sending them into the solar system. And equally, there was a paper in Science that more recently that said that, the fact we don't get hit by comets very often is a good sign, and Jupiter's doing its job.
I thought comets were coming into the inner solar system normally anyway, on their hyperbole orbits around the solar system.
Sure. Yeah, I mean, and you have all the objects coming in from the Oort cloud, and they're entering the solar system. And I suppose the question then is just whether or not, the presence of an object of the size due to the gravitational field and the strength of Jupiter's is enough to protect us in that way. If you look at the impact rate, perhaps it is. The fact that Jupiter's had 2 impacts in 2 decades, while fortunately the Earth hasn't had any, is a helpful sign. But I suppose you need several hundred years of data to be sure of something like that, at the very least.
There is also the argument that says, the reason we're seeing more impacts is purely because we're training more cameras and more telescopes on.
Well, there's a selection effect as well. It's an interesting question. I mean, I'm just thinking about the way in which people used to draw Jupiter a lot, and whether or not CCD work, I guess, is really able to pick these things out more effectively. I think it's probably an open question, actually. But I think it's a very good one.
Well, moving on from Jupiter and its abilities, with the recent Hartley 2 flyby by the Epoxy mission, what have we learnt from the various visits?
These started in the 80s, and I guess the main motivation was the fact that people knew Comet Halley was coming back and knew when it was coming back, and it was a bright and big object and therefore an appropriate target. And there was a whole flotilla of spacecraft went to see it. The Russians had some, the Europeans very famously had Giotto, and that was actually built in my home city of Bristol, just up the road from where I was born and where I lived. And it was the first chance, I think, to understand the heart of the comet, the nucleus, the bit that you just cannot really see very well from the Earth, because it's obscured by all the dust and material coming off of the comet. And we understood from that encounter and the others since that they were. Well, it's hard to say in retrospect whether entirely surprised, but I think with Halley it was perhaps a much more irregular shape than had been expected. This sort of peanut shape. I always find it interesting in astronomy. We tend to talk about things which are either spherical or peanut-shaped or potato-shaped.
It's always food, isn't it?
It's always food, and it's always some. Yes, peanut and potato covers virtually everything. So I've not heard of anything that's carrot-shaped yet. But anyway, joking aside, understanding the fact that this dirty snowball model, the idea that comets are a mixture of dust and ices of different things, not just water but frozen carbon dioxide or dry ice. That was vindicated by the Halley encounter, except that the surface was much darker than expected. And since then, we've had Vilp 2 and then the Braille mission that went past and another one, and they've all looked really quite distinct, which, in a sense, is not, I guess, what you'd expect, although equally they are of very different sizes too, and perhaps we shouldn't be surprised by that diversity when we see that in the asteroid belt and we see the whole range of things you can see there. So it reinforced the idea that you had not a sort of soft, fluffy snowball. There are these jets coming out of them, that there's sort of a crust, and that the jets that go on to make the tail erupt through that crust as it gets close to the sun.
It's interesting you say that when they looked at Halley, it was darker than was expected. I mean, is this something where they've estimated the brightness of the nucleus based upon the amount of sunlight it's absorbing?
I think that's based on the assumption of the size of an object, and if you don't see it up close and you don't have anything other than assumptions about either, well, in the case of cometary nucleus, a starlight point, or probably nothing from the Earth, then you make guesses as to its size, and that's what informs your idea. When it's further out and the activity's died down, you again run through those assumptions. But if it's dark, then it can be bigger than expected, because a dark object has to be bigger to reflect as much light in total as a smaller one that's more reflective. And I think that was the gist of what was discovered.
We just had the press conference from the Epoxy mission. What are the principal findings that have come out of that?
Well, this is a really great example of carrying on reusing a spacecraft and keeping it going after it's done its primary mission. What was Deep Impact was throwing something the size of a washing machine at a comet. But following that up, 5 years later, just in the last couple of weeks, it's gone past Comet Hartley 2, and it's found not only some great images and showing jets of material of dry ice coming out, but also today it's been announced that it's surrounded by storm particles, that it's got this sort of snowstorm of material around it, which presumably is all the ejecta of the interior of the comet coming out into space. But it's quite remote, and there's some quite remarkable images. So.
Yeah, again, it's another peanut, though, isn't it?
It's another peanut, rather than a potato or a golf ball in this case.
There's been this suggestion that it was formed by two nuclei spinning round each other and gradually the gravity over millions and millions of years pulling the matter together to form a bridge.
That's possible. I mean, I suppose that, when you think about where these things formed really a fair way out in the solar system, even before they migrated to the Oort cloud. So, those same sort of processes that form asteroids must have gone on too.
What sort of records does the RAS keep of comet observations?
Well, we don't have, what we don't have is enough contemporary records, although we do, of course, have journals that, if discoveries are made and if they're published, then they end up as a paper in one of our journals, like the monthly notices, the Royal Astronomical Society, which actually has so many papers in it these days that it comes out 2 or 3 times a month. But if you go back and you look at the historical record, that's very interesting indeed, because we've got lots of illustrations of comets in the days before photography, when artists would seek to capture them. So all the sort of great comets of the 19th century, like the famous one Donati, which I think is famous for having 6 or 7 tails, seen in the 1830s. And our records actually go right back to the 16th century. We have a book by Petrus Appianus called Astronomy for the Emperor, published in Ingolstadt in Germany in 1540. That was one of the first ones to collate observations of comets and showed the idea of the comet's tail rather streaming away from the sun. As well as the Petrus Appianus, but we also have holdings like we've got Caroline Herschel's drawings. We've got some of the earliest photographs of comets as well. One taken by David Gill of the Great Comet of 1882 from South Africa. So there is a real historical treasure trove. I mean, it's really available to professional researchers and historians and so on, but there's a lot of material there, some of which is actually online, not necessarily on our website, but you can get it reasonably easily from the Science Photo Library and elsewhere. But we do have a real role in keeping hold of that stuff. Do
you think that the Tunguska impact was caused by a comet?
Well, I think I will say certainly that I don't believe the Tunguska impact was caused by an alien spaceship or some weird sort of natural nuclear explosion or some of the exotic explanations that have been offered. The comet model fits on some levels because it's an impact that doesn't appear to have left very much in the way of debris at all, and when there was a Russian physicist who modelled it a few years ago and demonstrated that the comet coming in at a narrow angle, exploding, would more or less produce the pattern of, well, not craters, but the blast pattern that was observed. So it seems like a good explanation to me. Having said that, more recently there's been an Italian group looking at the sap in the trees of Tunguska, and they're putting forward the idea that consistent with an asteroid. But having said that, I mean, if it was an asteroid, it's very, very much destroyed itself in the explosion, because there doesn't seem to be anything in the way of rubble left behind, which is slightly surprising.
Robert, thank you very much for coming on Under British Skies.
No, that's an absolute pleasure. Thanks again.